Hello there, it's Dr. P, and this video is about BCD codes. BCD stands for Binary Coded Decimal. It's binary, but its purpose is to store decimal numbers. Decimal numerals go from 0 through 9. Therefore, we require 4 bits of binary, called a nibble, to represent each decimal character. Let's look a little bit at the anatomy of a decimal number. We'll use 16,452 as our example. While you might think of this as being one number, it's actually made of 5 different digits. Because it's a decimal number, there's a ones place, a tens place, a hundreds place, a thousands place, and a 10,000s place. We would therefore need to use 5 BCD digits to store this number. Each of the places gets its own nibble, and the decimal number is encoded in that nibble. We tend to use a lot of decimal numbers in our lives, so it's useful to use binary to store these values in digital electronics. If I have a digital clock, it makes more sense for me to store each decimal number rather than to convert the time into binary and then decode it into each numeral to show on a clock display. As an example, I have a binary clock that has 2 modes to it, binary and BCD. I think it does a great job of making clear the difference between regular binary and BCD. In binary mode, the clock shows what time it is in binary. I have to convert this number to decimal to make any sense of the time. This top row shows me the hours, the middle row shows me the minutes, and the bottom row shows me the seconds. The hours are simple to decode because the hour was only 8 when I took this video. The minutes are 101101. I have to do a binary to decimal conversion to calculate the value as being 32 plus 8 plus 4 plus 1, which is 45. In BCD mode, the clock shows me what time it is in decimal, but each decimal number is encoded in a binary nibble. I still have to do the conversion, but it's much easier. Each column is related to the tens or ones place. Hours, minutes, seconds. It's much easier to figure out the time. Hours are 0 in the tens place and 8 in the ones place. Minutes are 4 in the tens place, 5 in the ones place, and then I could decode the seconds if I wanted to. This clock uses 8421 BCD. Those are the weights associated with each bit of the BCD nibble. That's the binary that we're used to, as each of those values are simply powers of 2. When I say BCD by itself, I implicitly mean 8421 BCD. This BCD code is so useful in digital electronics that there exists a logic chip that was built to take a BCD value and translate it into on and off values for a 7-segment display, which is the type of display you see in most digital clocks. There are other weighted BCD codes that can be used. Many of them were formulated for different purposes, which I unfortunately don't have time to discuss in this video. These BCD codes still serve the same purpose, encoding decimal numbers in a binary format. However, the weight of each bit in each nibble depends on which weighted code is used. 6311 BCD uses weights of 6, 3, 1, and 1 for each bit in the nibble. We can therefore derive a truth table for how to express each decimal number using this weighted code. We can look at each one of these nibbles and add up the weights of each of the bits. 0000 is the simplest, as we have 4 zeros summed together. Next, we would have 0 plus 0 plus 0 plus 1, which is equal to 1. Then we would have 0 plus 0 plus 1 plus 0, which is also equal to 1. So 6311 BCD code actually does give us repeats, and we tend to ignore the second repeat of each number in 6311 code. Next, we would have 0 plus 0 plus 1 plus 1, which is 2. 0 plus 3 plus 0 plus 0 is 3. We can continue to do this for each one of these 6311 BCD values to obtain a complete truth table. We see that all of the decimal numbers between 0 and 9 can in fact be encoded using 6311 BCD. Numbers larger than 9 are not BCD because they actually contain 2 decimal characters. Going back to our example decimal number of 16,452, we can express this in 6311 BCD by converting each digit as a 6311 value, using our truth table to help us do that. You may wonder if you could pick 4 random weights and create your own binary code. The answer is, depends on which 4 weights you choose. The 2 BCD codes we've looked at, 8421 and 6311, are said to be complete codes because they can represent all of the decimal numerals. But not all codes may be complete. Let's select 4211 as our weighting for a hypothetical BCD code. Just like we did with 6311, we're going to take each of the bits in our nibble, sum them up using the weights to see what decimal value they represent. 4211 is therefore an incomplete BCD code because there's no way to express the number 9. Hopefully this video gives you a better understanding of BCD codes and what they're used for. Until next time, stay well.